Mm. Yeah, in this video we are going to talk about various silicon crystal growth mechanisms from the melt. Among them, Czochralski technique and float zone process. Uh, Float zone process. These two are most commonly used to prepare single crystal silicon from the melt. Among them, more than 90% of the silicon in semiconductor industries prefer Czochralski techniques is one of the method, and also more commonly used in semiconductor industry. So in this lecture we are mostly going to talk about Czochralski technique only. So in this Czochralski technique, input raw material for this technique is electronic grade silicon, which is a polycrystalline silicon obtained from the metallurgical grade silicon. If we and this Czochralski technique is based on crystal puller mechanism. It has mainly three parts. One is crucible, which also include fused silica, crucible, which includes fused silica crucible and quartz also. And a second one, crystal pulling mechanism. Which has seed holder and seed holder, and also include a rotation mechanism. Further, last one is the ambient control, which has argon gas flow and exhaust gases for that exhaustive system. So, and also to control process parameters, there is a microprocessor system. Here process parameters are like temperature, pulling rate, crystal pulling rate, rotation speed, crystal diameter. These are few process parameters we can control to closely achieve the uniform single crystal silicon from this Czochralski techniques. How this mechanism works, here we can see that mechanism for a single crystal silicon growth. Here we already talked that input material for this mechanism is polycrystalline silica in a liquid form. This polycrystal silicon is EGS grade. This is placed in a crucible and melt at temperatures greater than 1500 degrees centigrade or equal, because melting point of silicon is silica is 1410 degrees centigrade. To melt this, we have to keep temperatures a little bit more than melting point of this silica. So now keep a seed crystal onto the seed holder, and then dip into the melt, so that when dip into the melt, and thereby at the solid liquid interface, solid and liquid interfaces will be in between, single crystal seed and melt. So now this melt can be slowly withdrawn. So now this seed crystal slowly withdrawn from the melt. This single crystal maybe of 100, maybe of for example 111 direction. Whenever the seed crystal withdrawn from the melt, it is slowly freezing takes place, and then slowly freezing takes place, and then a single crystal single crystal interface yields a large crystal, large single crystal. So here here in this single crystal, uniformity can be achieved. Uniform can be achieved by carefully control the pulling rate and rotation speed. Which leads to obtaining a high quality single crystal. If someone needs a dopants, then we can add into the silicon melt, thereby achieve the dopant thereby achieve the dopant crystals also. Yeah, with this we can conclude this topic on czochralski techniques. Yeah,